On this part we'll be building 3 of our general purpose registers here on this segment below our display decoder, and we'll build this register using the 74HCT377 flip-flop, and this is an 8-bit flip-flop, D-type flip-flop. It's a register, so to say, 8-bit register, and it's fairly compact because we get the 8 bits in just one package, with a little downside that it doesn't have a clear pin. So when we start the computer, when we power it up for the first time, we might get some garbage stored in the register, but that doesn't really matter because we shouldn't be reading anything from the register before we write it anyway. So we can leave. I think we can leave that, and we will interface each of the registers with our tri-state bus transceiver, the 74HCT245, the same that we already used on our program counter. We also will use some LEDs to display what's in the register, except for one of them that I will hook up to our display decoder. For the registers, the schematics are all very similar and very simple. This here, for example, is the register C, and it has the 74LS377 and the 74LS245 bus transceiver and 8-bit register, and they're connected in this loop, so to say. We acquire the data from the bus into the register, and then from the register to the transceiver, and we also have the display LEDs, so that we'll know whatever is stored in the register. And it's pretty straightforward schematics. The difference to other registers, this was register C, register D, is absolutely the same. I'll just show you just for reference. And the difference to register A is that register A has outputs here to the decoder, to our binary decoder, and actually register A hasn't got any LEDs here, so I can as well just delete these LEDs. Register A has no LEDs but the decoder. Okay. And register B has the LEDs, but the output is also directly connected to the ALU. That's why we have this difference here, as we can see here in the main schematics. And the stack pointer is also the same as register B or as register C or D. It's just a register with LEDs. So now that we have shown the schematics, we're good to go and build the registers. In the setup here, I also have the other 2 general purpose registers showing its values on these LEDs, the yellow and red LEDs. Also with the programmer emulating a 8-bit bus. Another experiment we could make is to transfer values from one register to the others. For example, this 255 that's stored here, or this 196 that's stored here. Let's do that. Let's transfer this 196 to this side of to this register here that has this 255 stored. And to do that, I'll enable the output of this register. Let's enable the output of this one. Yep. Then enable the input of that one. And then I'll post the clock. Voila. There we have it. So I guess we could call this as a success. It's working well.